This is a video for Lesson 4.3, Writing Linear Equations in Point-Slope Form. Now, we've already talked about how to write linear equations in slope-intercept form. This is just an alternate way to write them. It says the point-slope form of an equation of the non-vertical line through a given point, and that's going to be x1, y1, with a slope of m, is y minus y1 equals m times x minus x1. So a couple of things here. First, it only works for non-vertical lines. Second, we're given a slope and an ordered pair. Now, these are put into that point-slope form. So this y1 and this x1 and this m are actually all going to be numbers. So just making up a random example of something in point-slope form, we might see something like y minus 3 equals 5 times x minus 2. Okay, so there's not going to be all these variables here, but we will have that y and that x with an ordered pair put in and that slope. So why does this work? Okay. Looking at our point-slope form, y minus y1 equals m times x minus x1, if we look at this diagram, that y minus y1, that's that vertical change between those two y coordinates, also known as the rise. That x minus x1 is that horizontal change between those two x coordinates. Okay, that's what we know as the run. And that m represents the slope, and we know slope means rise over run. And once again, while it might seem strange, over here we have rise over run times run. Those runs kind of reduce out, and we have rise equals rise. So our equation does make sense. Okay, we're just writing in a different form, and both sides do equal each other. So let's actually do an example of writing an equation in point-slope form. It says write an equation in point-slope form of the line that passes through the point 4, negative 3, and has a slope of 2. So first we're going to write our point-slope form. And this is something that you kind of just got to memorize. We have y minus y1 equals m times x minus x1. We're going to substitute our values. We know that our slope is 2, so that's going in for our m. And our ordered pair is 4, negative 3. So we're going to say y minus, our y is negative 3. And over here we're going to say x minus, and our x coordinate is 4. And I said we have to simplify because if we look here, we do have that double sign, which we do need to fix. So on our left-hand side, we end up with y plus 3. And on the other side, we leave it as 2 times x minus 4. Okay. Please don't distribute. This is how point-slope form is written. Let's try B. Write an equation in point-slope form of the line that passes through the point 3, 5 and has a slope of negative 1. Step 1, write your point-slope form. Y minus y1 equals m times x minus x1. Fill in your information. We have a slope of negative 1. We have our coordinates of 3, 5. So we're going to say y minus, and our y is 5. And then negative 1 times x minus, and our x was 3. And it looks like we're done. However, there is something there that we don't need to write, and we want to get out of the habit of writing down things that we don't need. Okay, right here, we see that this is a negative 1 out front. Well, we don't need that one. So let's rewrite it as y minus 5 equals a negative x minus 3. Okay. Try the checkpoint question on your own, so please pause the video. This will be checked in class tomorrow. Now let's move on to example 2, graphing an equation in point-slope form. So we're graphing the equation y plus 2 equals 2/3 times x minus 3. Now because point-slope form involves subtraction, the coordinates are actually the opposite signs of what's in the equation. So if we're looking at y plus 2, that means the y-coordinate is really, if this is a plus 2, the y-coordinate is really negative 2. And then over here it says x minus 3, which means the x-coordinate, sorry guys, fix it on your paper, means the x-coordinate is a positive 3. Okay, so when you're taking the ordered pair from the equation, you gotta take the opposite of what's there. So our ordered pair is 3, negative 2. So you're gonna graph that. So we're gonna say here, I'm gonna change to red. Here's 3, here's negative 2. So here is our first ordered pair. Then from that, we're gonna find some more points. Our slope is that 2/3, which we know means to go up 2 and 3 to the right. So starting from that ordered pair we just graphed that we found, we're going to go up 2 and then 3 to the right. You guys know by now that I like doing as many points as we can, but we can't go any more in this direction, so let's go the opposite way. Let's go down 2 and 3 to the left, and then down 2 and 3 to the left. Okay, and now we have all of our points. So we're going to connect them with a nice kind of straight line. Hopefully yours is better. Can't use a ruler on my tablet. And we have our line. Okay, please note that this is very similar to graphing things using slope-intercept form. The difference is your starting point. When we do slope-intercept form, our starting point is that y-intercept. And from there, we use the slope to move over. For point-slope form, you start at the ordered pair that you find from that equation, but then still use the slope after that. Next, you'll find another checkpoint, so please pause the video and try it. And when you're ready, hit play again. Let's look at example 3 now. Writing an equation in point-slope form from a graph. Going to be just like our first example, except now we have to find that slope. So looking at our graph, we could use our slope formula if we wanted to, but I'm just going to count some boxes. Okay, starting from -1, 3, we have to go down 2, and down is a negative direction. And then from there we go 2 to the right, which is a positive direction, which means our slope is -1. Now we're going to write down our point-slope form. Y minus y1 equals m times x minus x1. You have 2 points. Choose one of them. It doesn't matter which one. I'm going to try -1, 3. So we're going to say y minus, our first y is 3, so y minus 3 is -1 times x minus, and it's a -1, so minus a -1 would become a +1. And once again, we don't like writing that -1 out front. We don't need it. So we do y minus 3 equals negative x plus 1. What if we'd used the other point? Let's try it. Y minus y1 equals m times x minus x1. But now we're using that 1, 1. So we'll do y minus 1. Our slope is -1 still. And then x minus 1. And we get y minus 1 equals negative x minus 1. Now it might seem strange because these two answers are different. Okay, but they are both acceptable answers. Let's verify and check to make sure that they really do equal that same equation. Okay, we have a little room down here, so I'm going to say, let's write down that first equation. Let's try to get it into slope-intercept form. So first, we can distribute that -1, so it's negative x minus 1. And if we add 3 to both sides, we get y equals a negative x plus 2. So now we just took this point-slope form and put it into slope-intercept form. Let's try the other one, which is y minus 1 equals negative x minus 1. So once again, we distribute the negative, negative x, this negative times the negative 1 becomes a plus 1. And if we add 1 to both sides, we get y equals negative x plus 2. So even though our point-slope forms look very different, if we change them both into slope-intercept form, we see that they do equal the same equation. So on a quiz, I would accept either of these answers. On the next page, you'll find a checkpoint, just like example 3. Please complete this, and then hit play when you're done. Once again, we will check these 3 checkpoint questions at the beginning of class tomorrow. Now for some word problems. Example 4 says, solve a multi-step problem. You are designing a sticker to advertise your band. A company charges $225 for the first 1,000 stickers and $80 for each additional 1,000 stickers. Write an equation that gives the total cost in dollars of stickers as a function of the number in thousands of stickers ordered. Find the cost of 8,000 stickers. So it's good to note that we're talking about the number of stickers in thousands. Okay, so if we're talking about 8,000 stickers, we're really just going to say 8. So step 1 says identify the rate of change and a data pair. So we're going to say let C be the cost in dollars and S be the number of stickers in thousands. Okay, our rate of change, okay, after that additional is going to be $80 for, $80 per 1,000 stickers. That's how much it's going to increase by each additional time. A data pair that we have would be 1,000 stickers, but instead of saying 1,000, we're going to say just 1. And that 1,000 stickers, let's see. It's going to be $225. So we had to find the rate of change, and we had to find one of those ordered pairs. Okay, remember this is number of stickers and then cost. So we're going to write our equation. Y minus y1 equals m times x minus x1 is going to change a little bit because we're talking about a word problem and we don't have x and y anymore. Okay, but C is that total cost, okay, which is that dependent variable, so that's going to be like our y's. So we're going to say C minus C1 equals the slope times, instead of x's, S minus S1 for the stickers. So we're going to say C minus, and our first C was $225. We're going to say $80 is the rate of change, and then S minus 1. So that's our equation in point-slope form. However, it does say to write it as a function of the number of stickers ordered, meaning we should put C by itself. Okay, so let's distribute. We have C minus 225 equals 80S minus 80. We add 225 to both sides. We get C equals 80S plus 145. So that, undo that. That is our equation as a function of the number of thousands of stickers ordered. So now we're going to find the cost of 9,000 stickers. So the cost is 80. And if we're talking about 9,000 stickers, we're really inputting a 9 plus 145. This is 720 plus 145. That means altogether it's going to be $865. Finally, example 5, writing a real-world linear model from a table. The table shows the cost of visiting a working branch for one day and night for different numbers of people. Can the situation be modeled by a linear equation? Explain. Let's do that first. Okay, it could be possible that the more people that attend the ranch, the less they pay. They could be getting a discount if more people are coming. So we need to make sure that this actually can be modeled with a linear equation. And to do that, we're going to make sure the rates of change are the same. Okay, so from the first column to second column, the cost goes from 250 to 350, so we subtract, and then 6 minus 4. Okay, that gives you 100 over 2, which equals 50. From 6 to 8, it's 450 minus 350 over 8 minus 6, which is 100 over 2, which is 50. From 8 to 10, 550 minus 450 over 10 minus 8, once again 100 over 2 equals 50. And the last one, 650 minus 550 over 12 minus 10, 100 over 2 gives you 50. So the rate of change is the same for each one, meaning it can be modeled with a linear equation. So we're going to say rate of change is constant. So now we're going to write an equation that gives the cost as a function of the number of people in the group. So we can start by writing it in point-slope form. So I'm going to say y minus y1 equals m times x minus x1. Okay, but now we have to plug in our other variables. Our y's are like our cost. So c minus c1 equals, and we'll say m, and we'll say p for people. So p minus p1. Choose one of your ordered pairs from the table and plug it in. Okay, let's do 250. So we'll say c minus 250. The rate of change was 50. And then p minus 4. So that's our equation in point slope form. Let's change it so that the c is by itself. We have c minus 250 equals 50p minus 200. Add your 250 to both sides. You get c equals 50p plus 50. Okay, that's it for today's notes. Please make sure that those 3 checkpoint questions are completed for tomorrow also, as they will be checked as part of the homework.